Okay, good morning, Year 11. I hope you all have had a great break and had a chance to do some bit of relaxing. Obviously, this isn't how we expected to be coming back into your learning in 2021, but we deal with what we get. And obviously, the plan is for you to be back in school next week, taking your mock exams, which will obviously, as I've said many times before, give you a very good idea on what you need to work on. It'll give us a really good idea as staff to decide what we're going to cover over these last few months that you've got left at the Warwick before those exams. So this week you've got 4 remote learning lessons, each of which is an hour long, which gives us a good amount of time to get the revision in. It's only slightly less time than you would actually have if you were in school. For your lessons, you're going to have today's lesson. You've obviously got this video from me. Tomorrow I'll run a live lesson. Thursday will be another video lesson with some worksheets, and Friday will be another live lesson. This is obviously going out to both students in 11N and 11O. We've looked at what we need to do over both classes, and there's a big overlap on topics we need to work on. And as you can see for today, we're going to be starting with compound interest and tree diagrams. However, we've got to do it now task to begin. As you can see, you're allowed a calculator for this, and I suggest that you pause the video now to work through this do it now task. All right, I'm going to move on to look at the answers. So question A there, a square has an area of 30 centimeters and you're asked to work out its perimeter. So it's got an area of 30. That means we've squared the sides to get an answer of 30. So to find out what one side is, we have to take the square root of 30. As you can see there, the square root of 30 is 5.477. I'm just going to grab that just so I can indicate things as I go through. 5.477. So each side on this square is 5.477 centimeters. For the perimeter, there's 4 lots of those, so we do 5.477, multiply that by 4, gives you 21.91, and we should put that as 21.91 centimeters, making sure that we include the unit. So that is your answer to question A. For question B, you've got a right angled triangle. We're looking out to find a side length, and we've got 2 side lengths. Unsurprising, that means we're going to use Pythagoras' theorem. Now, we've already got the length of the hypotenuse at 9, and we need to work out another shorter side. So we do a squared, our rule is a squared plus b squared equals c squared. Because we're finding a shorter side, we subtract, we do c squared minus a squared. So 9 squared minus 6 squared, 81 minus 36 gives us 45. And then we take the square root of 45, remembering to do it, that square it, subtract it, square root it to give us 6.71 centimeters to 2 decimal places as our answer. So, as I said, our big picture, we're revising for the upcoming mock exams. These are all topics that we identified from the last set as things that we need to work on. And we felt it was a good use of this week to really focus on those. You can see we're looking today, compound interest and tree diagrams. You can see there's a couple of star tasks at the bottom. And if you do complete those, do let me know about them. And I will submit Warwick Star credits on the system for you going above and beyond to help with your revision. So, focusing with today, we've got our first question here. Sammy has £300 to invest. She has the choice between 2 bank accounts. At PSC, she gets 5% simple interest each year. At Driffield, she will get 4% compound interest each year. If she wants to save for 6 years, which bank pays more interest? I suggest you pause this and have a go at this for yourself before I go through the answer. So moving to look at the answer here. It's getting 5% simple interest at TSC. So we're going to look at that one first. Now, for simple interest, you only work out the percentages from the original amount. It's not working out and adding it on. That's compound interest. We'll look at that in a moment. This is you work it out from the original. So here we work out 5% of £300. You then multiply your answer by 6 to get the 6 years that she saves. So if you're doing those calculations, 300 times 0.05, which says each year she gets £15 in interest, which is 5% of 300. Times that by 6 gives you £90, which is the total over 6 years. So here at TSC, she'll get £90 worth of interest. Now, I've used a multiplier there timesing it by 0.05. You could do, as I got in the green speech bubble there, 300 divided by 10 is 3, and 3 times 5 is 15 to get that 5% as well. That should say 300 divided by 100. I'll just correct that there. Equals 3, then 3 times 5 is 15 to get that 5%. Now, at Driffield, you get 4% compound interest. This is different from simple interest. You can't just work out the percentage and multiply it by the number of years, because you add that percentage on each year. So you'd first of all work out 4% of 300, then add it on. Then you get that answer. You get 4% of that and add it on. And you do that a total of 6 times for each of the 6 years. So that's 6 times in total, 1 time for each of those 6. So for year 1, we've got 300, and I've done times 1.04. I've used the multiplier because it's the quickest way to do this. You could do 300 divided by 100 to get 3. 3 times 4 is 12, and then 300 plus 12 is 312. But you can see that's 3 different steps of calculation. This here is one single step, and you've got to repeat that calculation over and over and over. We can go through and do all 6 of our years and get an answer of £379.60. So with the compound interest, she gets £79.60 back. Okay, so actually it says that TSC gives the better value here. Now, just to keep on at Driffield with the compound interest, you saw there I multiplied by 1.04 6 times. I can simplify that by using powers for the repeated multiplication. So instead of doing 300 times 1.04, getting the answer, times 1.04, getting the answer, times by 1.04, I'm just do 300 times 1.04 to the power of 6. You can see that gets me that same answer, £379.60. Right, there are 6 practice questions on the board, on the screen there for you to have a go at. You should be using a calculator for do this. I wouldn't expect you to be doing this without a calculator, possibly for the simple interest ones, but definitely not for compound interest. I suggest that you give yourselves there's 6 questions, say 2 minutes per question. Some of you will remember how to do the compound interest really quickly. Some of you will need to look back at this. I'm going to give you, I'd say give yourself between 5 and 10 minutes working on this. I'll pause for a moment and then I'll go through and show you the answers. So, looking to give you the answers here. There are the different calculations for each one. As you can see, I've used multiples when calculating. Like I said, it saves you time. It makes it quicker to do, and it gets you there quicker in an answer. So that's a bit of revision on compound interest. It was something that came up from the mocks. It's something that people struggled with. And I would say that if you are still struggling with it there, send me an email and send me a message on Teams and let me know where you're still struggling with. I'll probably direct you towards using MyMaths. So if you want to go directly to MyMaths, do that first. Okay. So that was the work on compound interest. The second bit that we're going to look at, now is working with probability and using tree diagrams. Now this here is a typical sort of question that might involve using a tree diagram. You're told some information about the shirts and trousers that Ian has in his drawers, and it tells you that in the dark he picks out a shirt and a pair of trousers completely at random, and you're asked to draw a tree diagram for this situation. So to remind you of what they look like, you've got tree diagram here, which I have not got the basic one, which is annoying because I've gone straight into one that shows you how you work out the probability. But with this tree diagram, you can see that first of all, this section on the left, is just showing the 2 options for shirt. We've got option of picking a black shirt, option of picking a grey shirt. Then from each of those, you pick a black shirt, and then the trousers, you could choose black or grey. If you picked a grey shirt first, for trousers, you can pick black or grey. Now, each of those then gives a possible outcome. The one that I've got highlighted there shows the options if we're going black, then black. You could go black, then down to grey. Black shirt with grey trousers, or grey shirt with grey trousers, or grey shirt with black trousers. All of those are possible options. And you'll notice that for each one, I've got a fraction with it, which I've taken from my probabilities. If Ian's got 3 black shirts and 5 grey shirts, the probability of getting black is 3 over 8. 3 black shirts out of 8 shirts in total. The same thing with trousers. That means there I've got 2 black trousers out of 5, which if I've got 2 black and 3 grey, matches up perfectly. Now, the main bit of the question there was the probability of, remember that, just key memory point there. It's got P with brackets. That means what's the probability of? So it says, what's the probability of choosing a black shirt and a black pair of trousers? So we want this line along the top, black, then black. Now we multiply those probabilities together. We get those two probabilities, the 3/8 and 2/5, and we multiply them together here. And we're going along the tree diagram. Those branches multiply out. So we're multiplying our answers. And that gives us an answer of 6/40. It's an AND rule. Remember, an AND rule in probability means that we multiply. So we've got black and black, we're multiplying. And it gives us 6/40 of our answer. Now, our second problem asked about what if we, that's what I wanted. Just give me a sec. There we go. Our second one asks us for a probability of choosing a contrasting, so non-matching combination. So black and grey or grey and black. Now, when we do this, we've got to take into account all of our possible ways we could do that. Black then grey, which gives us 9/40, but then grey then black. Grey shirt and black trousers is a different thing from a black shirt with grey trousers. And they give us different probabilities here. So we've got these two different probabilities, 9/40 and 10/40. So to find out that total answer, we've got to combine them. Probability of that, well, or is adding in probability. 9/40 plus 10/40 gives us 19/40. So that's how we draw our tree diagram, how we can use our tree diagram. Now, this question here, it's a little bit more of a challenge, gives you a little bit of a different thing for getting the probabilities. I'll give you a moment to have a go at doing this. So pause the video, have a go at this yourself, and then we'll go through the answer. Okay, we're going to look at how this works. So our tree diagram, very much the same, yellow and green, yellow, green, yellow, green. Our probabilities 4 out of 9, yep, that's fine, 5 out of 9, but the probabilities here have changed. It's no longer 4/9. We picked yellow first, and this one's 3/8. This is different. It's not the same probability. Now, the reason for that is he took a sweet. If we started with 9 yellow ones and we took a yellow one out, that means there's only 3 yellow sweets left out of 8 sweets in total that are left. So our second sweet, the probability of getting a yellow, if we took a yellow first, is 3/8. There's still 5 green sweets, but again, it's only out of 8. It's not out of 9 that we had to begin with. Now, moving forward with this, we can then see what happens if we multiply our probabilities together. 4/9 times 3/8 is 12 over 72. That's our probability of 2 yellows. Then our different sweets match up. 4/9 times 5/8 is 20 70-seconds. 5/9 times 4/8 is 20 70-seconds. This time they do give the same probabilities. And then we just add them together as before to give us 40 70-seconds. Now, that second example is an example of events that are not independent. They're ones where what happens changes depending on what has happened previously. Often it comes up when things aren't replaced in a problem. There you saw that we didn't replace the sweet after we'd taken it. Sometimes it can happen if the event relates to the probability what happens to begin with. Okay, so I want you to do now a couple of questions on this, and let me just, so I've now put some questions up on the screen. I'll go through them. I'll give you a moment to do each one if you want to just carry on working through from the video, but I've also uploaded this sheet separately onto Go for Schools for you to access. Okay, so you've got, that's the first question. Scrolling down to the second question. Moving on to the third question. Moving to the fourth question. The fourth question properly here without me having to mess it around. Then going to the fifth. And finally, the last question. Okay, so to make sure that your work here is recognized, you must do one of the following things. Either send me a copy of your work that you've done so I can give you credit for it and that you don't get an email from me saying that you've not done it, chasing your work up. Or there is a quiz on Teams. It's got 6 questions on, should be very quick for you to do, that you can do to complete and submit that, and that'll show me that you've done the work. I will be putting up the solutions for the tree diagrams questions up on Go for Schools as well. I hope you have a good rest of your Tuesday, and I will see you for your lesson on Wednesday, which, like I said, will be live on Teams. Have a good day, everyone. I'll see you soon.